Hey guys, Math 1700, TVM Solver. I just tell you, this is just worth the price of admission. You should run to, let me get this all straightened out here. Okay, you should run to the bursar's office and just like pay triple for this, just that you're getting ready to learn the coolest function on your calculator ever. Okay, maybe that's a stretch, but it really is some cool stuff. It's going to potentially save you money. I had a situation just recently where we bought a new car and paid some money down on it, financed a little bit of it, and the, uh, the car salesperson told me the rate I was getting, and then they brought back the contract for me to sign, and I noticed that the payment was only it was like $7 off. It wasn't like that they had reported it to me. They just said, well, your payment's going to be in this range based on your credit score. I knew my credit score was good, so I knew I'd get the best interest rate because I'd done my homework. But when I went to sign the contract, I hadn't told them that I had the calculator. I was over here calculating the payment. Well, I knew the payment was supposed to be right down to the penny, but when it came time to sign the contract, I noticed that the amount they had there was about $7 more. And you think $7, instead of $200 a month, it was $207. That wasn't my payment. I'm just throwing these numbers out. Isn't a big deal, but if you finance your car over, I say 60 months or even 72, you can do the arithmetic of $7 a month for 60 months. That's $420. So if the salesperson can get an extra $400, $500, $600 out of the sale just by kind of pulling a little bit of sneaky calculation on your payment, well, they're going to do that. Well, my feeling is, why pay the $7 extra, even though $7 isn't that much money? Why pay that? Well, guys, anyway, I'm going to show you something. A lot of times in math classes where people are like, when am I ever going to use this stuff again? And I saw something on Facebook this morning. Someone, being kind of a smart aleck, said, oh my gosh, another day I've survived without using algebra. Well, the fact of the matter is, most of the things that I teach you in algebra, if you ever take an algebra class from me, for example, let's say that we're going to solve something like this, and we can, of course, solve it like this, and we can see that our roots to this are 2 and 4. There's a really, really good chance that you're going to go through life and never work a problem like this. There's a good chance that you'll never go in for a job interview and they'll ask you if you can work a problem like this. You get the job. Doesn't work that way. There are people who use algebra, me and other people, but guys, what I'm going to show you here is something that each and every one of you will use, okay? And it's called TVM Solver. Now, if you go on your calculator, you've got an apps button. Let me hit the focus key here to see if we can get a little bit better picture. All right, a little bit better. Well, if you hit the apps button, you'll see the first thing what you get is probably finance. Okay, so if you hit enter or scroll down, whatever you got to do, select finance. Well, what happened there? Okay, and the first thing you'll see is TVM Solver. Okay, I don't know why they call it TVM Solver, but they do. And when you get TVM Solver, you get a lot of different options here. Now, what I want to do first of all is I want to go through what each and every one of these means to you. All right? So the first thing that we see is we see n equals. This is the number of compounding periods. I'm running out of place to, well, I'm going to take this away and I'll bring it back. So what this is usually using the notation that we've used so far, this is going to be n times t, where t is the number of years and n is the number of compounds. So for example, if we do monthly, n is going to be 12, and if we do 5 years, t will be 5, so 5 times 12 would be 60. So this cap N that we put in our calculator is equal to 60. The next thing you'll see is I%. I% is just the annual interest rate. And you're going to enter this as a percentage. So if you have 5%, you enter it as 5. You don't enter it as a decimal of 0.05. Okay? The next thing that we run into is this PV. PV just stands for present value. Now, present value can mean a lot of different things, but it's entered as a dollar. The next thing you see is your payment. And that says entered as PMT. Now, guys, your payment over the next few weeks is going to take on a lot of different meanings. Payment may be something we're trying to find to amortize a loan. Let's say we want to buy a $200,000 house and we want to pay payments over 25 years. Interest rate 5%, yada, yada, yada. What would the payment be? Well, payment may be something that we calculate. Payment may also be something that we use in the context of the problem to come up with the future value. For example, maybe we want to put down $10,000 in a savings account and we want to add $100 per month to that initial account. So the payment may be something that we solve for, or it may be something that we include in the type of problem that we're trying to solve something else for. Okay. Speaking of FV, future value. And guys, future value may be something we solve for, or it may be something we enter a number for. For example, let's say we're amortizing a loan for a house. So again, we buy this house for $200,000 and we want to calculate the payment to pay it off. Okay. Well, our future value is going to be 0 in this situation because we want to do, be a good credit person, a good customer for the lending institution. So we want our future value to be 0. So we start out with the amount that we pay for the house. Our future value will be 0, and we could calculate the payment based on the interest rate and the number of periods that we want to amortize the loan over. Guys, the next two things we see are PY and CY. PY and CY are always set the same number. And they're always set at this N back up here. PY and CY are nothing more than the number of compounds per year. So if we're buying a house and we want to buy the house, pay monthly payments, then in that situation, N would be 12. If we're working for a company and the company wants to buy a new computer or set of computers and they want to finance this over quarterly, make quarterly payments, then N is going to be equal to 4. Again, the number you use up here to get your total number of compounds. This is just the compounds per year, not the total number of compounds as we use in cap N. A lot of times in businesses, you will want your payments coming due one time per year. Now, you're going to pay more interest that way, but sometimes you have businesses that have peak periods where your cash flow is better and you want your payment to be one time per year. For example, when I used to own part of a golf course, and we bought some golf carts. We bought 25 golf carts, and I think the golf carts were about $4,000 a piece. So we borrowed about $100,000 to buy some golf carts. Well, I wanted my payment one time a year. I wanted it due in August because, guys, in Kentucky, your golf business is prime in May, June, July, and August. So May, June, July, and August, especially August and September, by the time we just finished our summer, we felt like we were millionaires because that's when our cash flow was the best. Unfortunately, in the golf business in Kentucky, when you get to January, February, you feel like you're broke because you've spent all your money from the previous year. So because you just don't have much golf played in the state of Kentucky in February for obvious reasons. Kind of hard to play golf when there's 19 inches of snow on the ground like last year. All right, gang. So PY, CY are always set the same. Now this thing down at the bottom, payment, end, and beginning. First of all, I'll just go ahead and tell you for this class, we will always set the end key. Now, if you could accidentally set this as beginning, you're going to miss all the answers because it does something different. And this is actually set up, real fancy terminology here, is something we call an ordinary annuity. Ordinary annuity is something where the payments are made at the end of the period. Now, I don't know if you guys have ever bought a car, bought a house, but if you've ever bought a house or ever bought a car, and you're going to buy a car, and you finance some of the car and make monthly payments, for example, what'll happen is you'll go in and buy your car, and let's say, for example, you buy your car on December the 12th. Well, what they'll do is they'll give you the money on December the 12th, but they'll tell you that your first payment isn't due until January the 5th, or 15th, I'm sorry. And most people walk out there thinking, boy, that bank sure was nice. They gave me one entire month to kind of collect my finances before I actually make my first payment. Well, this is making a payment at the end of the first period. This is a month later if you're making monthly payments, so right about it. It won't turn out exactly, but they do some fancy-smancy way to get the most money out of you. So that's called an ordinary annuity, where you make your payment at the end. Now, you think they're doing you a favor. Really, they're not. The best thing you could do is just go ahead and say, no, I want to make my first payment today, December 12th. Because you think about, if you borrowed $20,000 for a car, what'll happen? That entire amount will sit there for the next 33 days, or whatever it turns out to be, and draw interest. Or not draw interest, it will cost you interest. The amount that you owe, if you do your stuff on time, don't get into penalties and all that stuff, the amount that you owe will never be bigger than the first day. And the bank will never get more interest on their money than they will for the first month. And we're going to really see that evolve once we get into spreadsheets for our calculation of periods and interest and so on and so forth. But we'll get into all that stuff later. Now I got a spreadsheet I want you to take a look at, and you might say, well, Dr. Darbo, you're losing your mind. We've already worked that one. I know we have. The purpose of this is to rework the problems from the previous video, the previous handout, but this time I want us to use the TVM Solver key instead of using those fancy formulas. So guys, you must keep in mind that this TVM Solver option works only for problems that are compounded n times per year. Anything that uses the simple interest formula, the TVM Solver does not apply. You work those exactly like you used to work them. It also doesn't work for continuously compounded. I'm sure you remember this formula that I introduced a couple of videos ago. It doesn't work for those, okay? So if we work through here, it says use the simple interest formula to find TVM Solver does not apply. It's not a compounded problem. So we'd work that one just like we did in the previous video. Use the simple interest formula to find the number of years when TVM Solver does not apply. This is a simple interest. This is using I equal PRT. This formula is used behind the scenes for TVM Solver, but we don't use it. Use the appropriate simple interest. Does not apply. How much interest will you have to pay for a credit card of $3,500, 7 months overdue? Guys, another key, if you have something less than 1 year. TVM Solver does not apply. If you paid $75 to a loan company for the use of $1,200 for 182 days, less than 1 year, TVM. Probably sitting there thinking, when the hell does it apply? Well, trust me, plenty. Radio commercial for a loan company, yada, yada, yada. You borrow for 269 days, less than 1 year. TVM Solver does not apply. Number 7, use the continuous compounded interest. Well, we got one of the words we need, compound. But continuous, guys, you got to use that formula. If $800 is invested at 9.5% interest compounded daily for 20 years, so we got compounded, not continuously, we got more than 1 year, TVM Solver applies. Now let me show you how we do that, okay? So what we're going to be doing is we're going to be working this problem right here, number 8, and using the formula. I forget, I don't have the answer anymore, but we're going to work at using, get that where you can see it, okay? So guys, go into TVM Solver, and let's just walk down through what we want to walk down through, okay? First thing is we're compounded daily, so that tells me that I have 360 as my N. And I've went for 20 years, so I have to go times 20. So again, this N, as I said earlier, is your N times T. Compounded daily, this is 360. For 20 years, your T is 20. What did I do wrong? Oh, I put a double whammy in there. So there's going to be 7,200 total compounds. The next thing we need is the interest rate. Well, guys, usually you have to put in 0.095, but because this tells you it wants the rate as a percentage, you use the entire 9.5, not as a decimal. The next thing we want is the present value. Well, we're investing $800. So that's what we start out with. Guys, there's no payment here. We want to come down and make sure our PY and CY are set at the end. Since we're doing daily, this is going to be 360 for both of these. It even kind of dummy proofs it. When you put 360 in for PY, it will automatically change your compounds per year to match your periods per year. So PY is periods per year, this is compounds per year. These things will always be the same in this class. Again, don't get sloppy. Make sure you have ending there. Now, if you come back up and hit FV, highlight the one that you want to solve. You've got to have all the other entries in there except for one, and that's the one you want to solve, and that's where you go highlight before you hit solve. Well, guys, the solve button is right here. I'm pointing to it. It's green. So that tells me I got to hit my green key first and then hit solve, and it will tell me that this money will be worth $5,347.38. Now, a little bit annoying, it'll show you that as a negative. And I don't really understand why, because I've really never cared enough. I just remember that it's not negative. This is treated as positive. But long story short, PV, PMT, or FV, one of these three has to be negative. And we're going to run through situations where different ones are negative at different times. So if you're solving for one of these, just let the negative take its place. But if you're up here solving for maybe an interest rate that you're getting, and you'll have entries for all three of these, just keep in mind that PV or FV has to be negative based on the characteristics of the problem. That's just part of the stuff that we've got to learn, okay? Number 9, is this a TVM solver? When an IRA has $25,000 in it, the owner decides not to add any more money to the account other than the interest earned at 3.5% compounded monthly for 15 years. So it's compounded monthly, so it applies. More than 1 year also applies. So guys, TVM solver is the key for us in this situation, okay? So guys, let's go up to the very top and just very patiently go through. So we're compounded monthly times the number of years, which is 15. Our interest rate is 3.5%. We start out with $25,000. We're not going to add anything to it. I want to know my future value, so I'm going to set that at 0 right now as a placeholder. In my periods for year, because I'm doing monthly, both of these will be 12. So in this case, I'm going back up. I want to charge for my future value, or I'm sorry, solve for my future value. So green key, enter. So guys, the correct answer here would be 42,229.19. Now, that last problem, what would have happened if we had worked that with the formula? This problem right down here, if we had worked it with the formula, what would have happened? Well, we would have used this formula. So our principal is 25,000. Our rate is 0.035. When we do calculations, we have to change to a decimal. Our N is monthly. And our is 12 times the number of years, 15. Now, if we're using the calculator, and again, I've done this before, but I just want to run through and show you how we do this. The first thing I'm going to do is I'm going to take the 0.035 divided by 12. I'm going to add 1 to that. And I'm going to raise that to the 12 times 15 power. I'm then going to multiply that by the 25,000. And you will see that you get exactly what we got before with the 42,229.19. Using the formula is cool. It's fine. It works. All right. But it's the TVM solver has a lot more application than using the formula. Now, just to get you kind of started, let's just go through an example of calculating a payment. This is usually if I'm in class. This is where I'll solicit information. I'll ask somebody if they're wanting to buy something, and then yada yada yada, whatever it may be. But so I'll just come up with something here. Let's say that we'd like to go out and we'd like to buy a boat. And we look around at boats, and we find that we can negotiate a boat, a pontoon, for $19,995. And we talk to a lending agency, and they tell us they'll go 15 years. And they tell us that they can give us an 8% annual interest rate. And we'd like to make equal monthly payments to amortize the loan. Okay? Well, guys, this is going to be really, really, really easy to find. Go to TVM Solver. So first thing is N, right? Well, making monthly payments over 15 years. So our cap in this case will be 12 times 15, which is 180. The interest rate that we were able to negotiate would be 8%. Our present value is $19,995. We want our future value to be 0 because we want to pay off our loan. And we want to make monthly payments, so PYCY would be equal to 12. Again, don't get sloppy and forget to have this as end down here. We go back up to our payment, and we hit our green key. So guys, your payment will be $191.08. It's that easy. Now, what will happen is, chances are, whoever's trying to sell this to you, and they're financing it for you, they could possibly come back and say, well, you got a really good deal. We're going to give you a payment of $208. Well, most people can't sit there and calculate this payment in their head. I can't. And I'm actually pretty decent at this stuff. I can't do it. I need my calculator. But I could calculate with my payment of 191.08. Now, you'll even have some people that tell you, well, that calculator's wrong. Well, no, the calculator's not wrong. They're wrong. What they're doing is they're trying to squeeze $17 more per month out of you, because that over 15 years times 12 months, they would have made an extra $3,060 on you just by juicing it up $17 a month. You might say, well, that's a stretch, but what if they came back at this? $195. That's only $3.92 more a month, but still $392 times 15 times 12, that's another $705 that they get out of you just by picking this up, a very, very modest amount. But do you think that would be worth it for the salesperson of this boat to kind of trick you out of $3 and something extra per month so they could pocket an additional $700 total on the loan? Absolutely, they will. And you might say, well, I don't care. I want the boat. I'll pay the extra $3.92. Well, yeah, that's fine. If that's the way you are, then go for it. But if you want to, really if you want to pay what you negotiated at the interest rate you negotiated, then you should pay the $191.08 and not a penny more. Okay, and they'll come back when you catch them in a lie. They'll come back with all sorts of crazy things. I bought a car. My wife bought a car a few years ago, and I'm not going to say the name of the car dealer in Lexington, Kentucky, but we went in and we negotiated a deal on an SUV, and we were going to pay quite a bit of money down. We were going to finance the remaining, and I'd already kind of done my homework. I kind of had a good idea, kind of a ballpark of what the figure was going to be, and when they calculated the payment for me at the interest rate they told me I was getting, it just didn't seem right. But I didn't have my calculator with me. I tell you guys, I just tell you right now, you're going to be the biggest geek ever. I'm going to turn you into the biggest geek ever. You'll never buy another car, another house, no whatever, without packing this geeky-looking calculator around while you're negotiating the deal. But anyway, I went out to the car and I brought my calculator back in, and you could see what because I didn't tell him I was a math professor, and I put the numbers in that didn't match up what the contract said. He said, "Well, let me see a contract." So I said, okay, but let me see it first. So I took a picture of it. I took a picture of the contract because I knew what he was going to do. He was going to go back and change it, and I wasn't going to have evidence of him trying to cheat me out of money. So I took a picture of it, and I'll tell you what, it's one of the, well, we actually didn't buy from that, but if you can catch them in a lie, you've got the potential to get the best deal ever. Because just tell them, hey, I'm taking this to, channel 18, channel 27, and I will show them what you're trying to do to me. So, guys, you can catch them in a lie. You got them. And so anyway, I was going to tell you the rest of the story. This particular dealership, he came back and he said, my manager said that I can't deal with you as long as you've got your calculator. And I'm like, well, why not? He said, well, we're just not going to deal with you. And I said, okay. So I ended up leaving and going to another dealership. And first thing I asked him, the dealer was, do you care if I have my calculator out? And he said, I don't care what you do. My numbers are going to be the same as yours. And so anyway, guys, there are honest ones out there, but there are others that will take advantage of you, and because it's just impossible to do all this in your head. So, guys, that's an example of TVM Solver. I'll show you one more example of something that's kind of cool. Let's say that and this will be something we'll get into. Let's say in this particular example right here, you buy your boat for $19,995 and your payment's $191.08, and you want to say, well, what if I wanted to add $50 a month to that payment? Would it help me any? Well, you could go in and go negative 191.08, and then add another 50, and you subtract it for obvious reasons, so your payment here would be 241. You can go up here in Solver In and see how much quicker you would pay that loan off and easily calculate how much money you would save by adding the $50. A lot of people will take out a loan on a house and they'll add $100 to the payment. So guys, this is cool stuff. I think my Math 1700 level class has become very popular at Shawnee. I hear, I get a lot of positive feedback on my student evaluations. I get a lot of positive feedback, just kind of hallway chatter and stuff like that. And I think the reason is the material that we're going to cover from here on out. It's not because of linear programming. It's not because of systems of linear equations and matrices, although those are kind of cool. The reason that my class, I think, has become so appealing to people is they remember the latter part. They remember learning this function, and they remember learning mathematics that will definitely apply to their lives. Okay, guys, that's all I got. The next video is going to be really cool, so get prepared to watch it. Take care.